Welcome everyone to another webinar of At Right Angles. It's the Math magazine that comes out 3 times a year in March, July, and November. So this is Swati here, and with me is Krittika, and today we are going to discuss about symmetry.
Yes.
So over to Krittika.
Hello, Swati. Thank you for calling me and making me do the worksheet with my students. I had a lot of fun that we will go around and discuss.
So your school is, can you mention the name of your school again?
Yes, so I teach in Future Foundation School in Kolkata, and that's an ICSE board school. And I follow your magazine in a regular basis. And so for the this tear out part, we had tried out with our students of class 8. And so some questions for you. So about the tear out section, it always feels interesting to see the tear out section, what is there in this issue and what was there in the last issue. So I feel excited to always follow it up. So can you tell me that how did this tear out section emerge?
Yeah, so that's a very interesting story. So we run this program called Masters in Education, Master of Arts in Education, and in the Azim Premji University. And as part of that, there's a 3 credit course called Curricular Material Development Mathematics. I mean, there are similar courses in language, science, and history, social science. So the math is just one of the 4. And in that course, we used to, I mean, the students are basically supposed to create a resource with full documentation. Now, as a stage rehearsal to that, or just to try it out, they are initially asked to create a resource based on dot sheets. And that's because dot sheets are quite versatile. They can be used in multiple ways, and so on and so forth. So over the years, as different groups of students tried various things with dot sheets, at some point my colleague and the associate editor of At Right Angles, Sneha, I mean, we kind of came up with the idea like, why don't we uh, collate this and this worksheet and develop worksheets, especially with dot sheets. So if you notice that, in fact, all the previous pullouts are actually previous tier outs are all actually based on dot sheets. Some are based on both kinds of dot sheets, some are based on just one kind depending on the topic, etc. And if you look closely, some of them actually mention the students who took
Yes.
this course, and
Yes.
that this is inspired by their project or their work.
Correct.
So that's basically how this whole section came about. That you know I mean, as a teacher, you probably find worksheets to be quite useful, and since dot sheets in particular has so much potential, why not try to harness it? And we thought that it can continue for some time. There are many possibilities, and so that was the whole point.
Okay, yeah, that is great because we are using it, and I hope that many teachers who are seeing they will also get inspired and start using in their own classrooms. About the topic in this tear out uh, worksheet, that why symmetry was chosen, because as a topic or a concept, as mathematics teachers we always push this topic at the end of the curriculum or end of the term, because we always see that this is very easy and children can get it in no time, and we hardly have time to complete our syllabus, so let's do all the decimal and fractions and percentage in the beginning, and by the end we will do all this fun thing. But honestly, hardly we have that time to do those fun things. So all the fun things gets lost out, and only the boring things are getting important. So how this idea of symmetry came on?
So this was one project by one of the students, Keshvi, and she is right now in our Chhattisgarh team. So
Okay.
she wanted to do something with aesthetics. Okay, something connecting math and aesthetics. And symmetry was one of the ideas that we thought she could explore. And she actually went about that, and to her pleasant surprise, discovered her creativity and all of those. So that's basically how it kind of came about. And so basically this is a polished a kind of, the seeds all came from her project, and it is a more kind of fine tuning it, and that. And the other thing is that I think we kind of ran out of ideas to do with dot sheets also, to an extent. So it's a combination of both.
Okay. So I have, when I've seen this worksheet, I thought that I also thought the same, that let me take it up at the end of the year, but
Uh-huh.
again it didn't happen. And actually then I made myself okay clear that let me do in the beginning of the year. So we
Uh-huh.
actually have done this work in the beginning of the session. They have just started their session in April, and we have done this as a part of a workshop for 2 days. And at the last day we have given this worksheet to the students.
Okay. So, would you like to first present what all you did with them? And maybe then we can discuss what they did and what happened and so on and so forth.
Yes. So this is a 2 day workshop we have done. So I'll just show a few pictures of the workshop and then some discussion on the worksheet.
Yeah.
Is it visible?
It's coming. Yes. Uh, yes, I can see the slides. You want to start with the slides, or? Yeah, sure.
Yeah. So
Yeah.
this is, you can see the glimpses of the workshop students in action.
Right.
So yeah, so this activities they were doing in the on the first day of the workshop. So they were exploring different lines of symmetry and symmetric designs, which we usually do with students,
Uh huh.
maybe from grade 5 itself. But this batch, being the COVID batch for 2 years, they didn't have the chance to do all this work in class 5 because we were online, and they hardly had any introduction to symmetry. So that was
Mm-hmm.
another point, and for that I thought that let me take them through from the beginning of symmetry and then the worksheet. So on the beginning part they had some symmetric designs to make and find the line of symmetry. And then want to show a small clip. Is the clip visible? And
Yes.
okay. So here I'm going to play it, but here what they were asked to do is they were asked to make a square, and they were the vertices of the squares. So four students made the squares, and they were asked to find different kinds of symmetry through movement. So let's just watch it for a while. So here one student is instructing them, as you can see, that you move along the diagonal, or you move along the midpoint of one side of the square. So like that, they had figured out the line of symmetry for squares and rotational symmetry for squares, that how the degree is 4. And similarly they had done with the equilateral triangle as well. So they made equilateral triangle uh, being the vertices of the triangle, 3 students, and they were rotating and seeing the degree of rotation of the equilateral triangle. Okay, so this is just some pictures that they were starting the worksheet with, the tear out worksheet. All right. So here we come for the on the tear out section, and there are loads of answers. So I had selected only few to discuss in this webinar. Hello, Swati. Can you see?
Yeah, yeah, yeah.
Yeah.
I mean,
Okay.
the
Okay. Fine.
equilateral look a little bit like acute isosceles, but that's just because of some formatting or something.
Yeah.
Yeah. So I'll
Correct. I
ask
had to
the
cross.
audience to imagine these to be equilateral.
Correct.
Yeah.
So these are the questions started. So this is the first one was done for the students, and they had to color all these 3. And
So
so,
can you just read out the question? I think the first one has only
correct.
one line of symmetry.
It is one line of symmetry and no rotational symmetry. So
Okay.
interestingly, the students took quite a bit of time to understand the first one itself, that how it does not have, I mean, it has a rotation line of symmetry and does not have a rotational symmetry. So
Mm-hmm.
some of them suggested that shall I cut it out and check? I said, yes, you can do that. So they actually cut out the equilateral triangles and they colored it, and they were turning and seeing that it wasn't happening, because they were not convinced that why it can't happen.
Mm-hmm.
So, so after they figured that out, I think the later parts were easier to
Mm.
follow.
Yeah.
And then the second one is rotational symmetry of order 3 and no line of symmetry. This
Mm-hmm.
also many took a lot of time, because they were landing up in some cases or the other, the line of symmetry was present, and I had
Mm-hmm.
to point them out that this is a line of symmetry, maybe
Mm-hmm.
sometimes help them with the mirror to see that
Mm-hmm.
the other side is also the same.
Mm.
Okay, so that is the second
So,
one. The
so
third one,
like they
yeah,
had access to mirrors.
they had access to mirrors, so I
Uh-huh.
made sure that on the both the days the mirrors are available. On the
Uh-huh.
first day they
Uh-huh.
had some activities with the mirrors, but for this day they, I mean, actually did not have, but I kept it handy because I
Uh-huh.
knew that they will need it. So
Mm-hmm.
some of them actually came and told me that can I take the help of it. I said yes.
Hmm. Hmm.
So
Yeah, because I mean, certain things appeared very obvious to some of us and maybe not so. So, I mean, these kind of aids help those who need them, and not everybody may
act,
need them.
yes. And one more thing I realized that the equilateral triangle, they took more than more time than the squares. I
Mm-hmm.
think they
Mm-hmm.
were getting used to the idea of, I mean, 2 lines of symmetry, then one rotational, one reflectional. So many lines of symmetry and rotational symmetry together. So after they were used to the idea, I think the squares were easier to do.
Mm-hmm.
So
Also, I think
yeah.
square is a more familiar shape than an equilateral triangle.
Yes, I think that is true.
Yeah.
And the degree of rotation also matters. So this,
Yes.
they were quite 120-degree rotation. They can't imagine 120-degree rotation, I think, in their head.
Yeah.
It's
Yeah.
difficult to
Yeah.
imagine.
Yes.
So, but
Yes.
so 90 is an easier angle.
Yes. Yes.
So the second one, this 2 lines of symmetry, this
Mm-hmm.
has an interesting story. For me, I thought that this will be a very easy question for the students. They will get it in no time.
Uh-huh.
But for this one, they have taken the I mean, most of them taken many time, I mean, a lot of time to do this. So, because they were struggling to figure out that how come this has only two lines of symmetry.
Mm.
So, some of them came to me and told that it cannot happen.
Mm-hmm.
They were just disgusted and irritated, and they have
Yeah.
spent a lot of time on that.
I mean, this was a kind of trick question that the moment you have two, you automatically end up getting the three.
Hmm.
So two doesn't mean exactly two. Yeah,
Exactly.
yeah. So I mean, the whole point was for them to arrive at that without giving them any hint. And I'm glad that some of them did, you know. And it's okay to be frustrated in that and all of that. So, but
Yes, and
it's all right.
when they, yeah, the third, when they realize that they have to color every part with the same color to arrive at the two lines of symmetry, they said, oh, this then all the lines will be symmetric. I said, yes, then the three lines, all the three lines are the lines of symmetry.
Yeah,
So yes, that was fun. Yeah, followed by the irritation. Yes.
yeah, yeah.
So
I mean, they probably felt cheated. If there is three, why were we told two?
exactly. Why was it written two lines of symmetry? Then I said it wasn't written exactly two lines of symmetry.
Yes,
So,
yes.
okay. And then the fourth one was a line of symmetry and a rotational symmetry. So this was also, I think, many took time.
Mm-hmm.
But rotational symmetry, since they have done in the second one,
Hmm.
so first they colored that, and they realized that if there has to be a line of symmetry, then they started
Hmm.
coloring the other half, and they realized
Right,
that they have
right.
colored
Yeah,
everything with the same color.
yeah, yeah, yeah. All six parts will be identical.
Yes.
Yeah, yeah. I
And
mean, the
these
whole point was
questions
for them
also.
to arrive at these conclusions themselves.
Correct. So glad that they were doing, and some of them were coming and asking us. But anyway, but it was a group activity which took
Right.
place. It wasn't a single individual activity, so they were
Mm-hmm.
working in a group.
Mm-hmm.
All right, so this is another kind of shading, as you were saying, the creativity
Yeah.
of this.
Yes.
So many students who actually do not like mathematics or do not like a lot of calculations, they were very interested and engrossed in this activity.
Uh-huh.
So that I found very interesting, uh, and they were taking time to shade it with lot of
Mm-hmm.
love and creativity and colors. So this
So
is
this
one
whole
such.
point of combining math with aesthetics, that seems to have
Yes,
been achieved with your students.
completely. Because if
Excellent.
even if yeah, even if they were not very comfortable, they are not comfortable with calculations and everything.
Uh-huh.
But I could see that they are comfortable with these colors. So
Mm-hmm.
why not? I mean, if we can generate some more worksheets like that, where actually they get motivated to work in a creative manner, I think
Mm-hmm.
that should be done for those
Yeah.
children.
Yes.
Okay. Let's now the some mistakes on it.
Yeah.
So this is the second one where rotational symmetry of order 3 and no line of symmetry. Uh,
I mean, it's a
so
part mistake. I mean, if
yeah,
you
it's a
put
part
the whole
mistake.
thing in
Hmm.
grayscale, then
Correct. So then one child from this group only came up and told actually that
uh-huh.
what if you rotate this? What will happen if you rotate it? So
Hmm.
then the other child realized that okay, the green won't overlap green. I mean, it will come over the blue and the yellow. So if
Hmm.
it has to be order 3, then it has to be of all same color.
Right.
So that was the part that the group discussion or the group work or the peer work were helpful, and
Hmm.
that every time the teacher was not intervening.
Excellent.
So then another is this, of course.
Ah, yeah. Trying to
So
have exactly two lines of symmetry,
two
probably.
lines of symmetry. and then
Yeah.
does not exist was the ultimate
Yes.
one, that it does not exist.
Yes. Yes. I mean, yeah, I mean, what he or she was trying to do is true. I mean, you can't have exactly two lines of symmetry.
Eh,
So, from that
Correct.
perspective, it is correct.
Yes.
Yeah.
So this is one, and then this is one line of symmetry and rotational symmetry. This was another mistake.
Yeah. So, again, like partly done, the line symmetry part is
Partly done.
done, but then
Correct.
rotational symmetry is missed. Yeah.
So they were having the confusion, right? Together, when we are having these two things together, this was becoming a problem for few.
Yeah. Yeah. Yeah.
Because usually what we do is we do this line of symmetry separately and rotational symmetry separately. We don't combine.
Mm. Yeah.
All
Yeah.
right. So we'll come to the squares.
Mm-hmm.
So this is again not looking like squares, maybe. I don't know.
Yeah, they're looking like rectangles. So again, imagine them to be squares.
Okay. So here, if you have, I mean, if the audience has the access to the symmetry tear out, then it will be helpful to understand, I think. I don't know if the reading, I mean, it is clear, the writing is clear or not. So shall I
It's
read
too
out
small.
each one?
Yeah, I think
Yeah.
if you can read out, then it will be good.
Correct. So the first one, the simple ones, it is exactly one line of symmetry and no rotational symmetry. So for this one, I had loads of answers because
Uh-huh.
actually this has a lots of coloring and many different students
Yeah.
has done it in a different manner. I have
Yes.
taken only
Yes.
one picture,
I mean
uh,
that in
but
that way it's
when
a open question.
yes. So that was
It
the
has
fun
a
of it. That in
yeah.
the same group they were getting four different answers, and all of
Yeah.
them were correct.
Yeah.
So that was
Yeah.
the fun. That okay, and they were coming and checking with me that is this correct and was that correct too. I said
Uh-huh.
yes, both of them
Yeah,
are
because
correct.
in math it doesn't happen that the same problem has multiple correct solutions.
Yes, yes. So they were happy with that. That all the things were correct.
Yeah.
And then the second one is only rotational symmetry of order 2 and no line of symmetry.
Yeah. Yeah.
Now this picture, what she has done, I was confused at the beginning because both of them are looking yellow, and
Uh-huh.
it is looking like both there are two lines of symmetry. I mean one line of symmetry I could see, but then she has told me that there are some dots, and
Uh-huh.
on
There's
one
this
thing
that
there are some dots.
little
Yes.
orange part that doesn't.
Yes, little
Yeah.
orange, which
So
is not
yeah,
actually
definitely
the
not doesn't have line symmetry.
lines of symmetry
Yeah,
and
so is this an
rotation.
example of a student trying to trick you?
Yeah, because she has done some other kind of thing as well.
Ah,
That
okay.
yeah, previous on hexagon also she has done something where I was confused that I can see there is line of symmetry, but she was telling
Uh-huh.
no ma'am, you see I have done this part and very small difference she has
Uh-huh.
made. I said okay
Ah,
fine.
okay.
Now I can
Okay.
see.
Okay. Okay.
And
So the
fourth one, the
last
numbers, yeah, the last
C
one
I
is
think
order
is
4.
yeah, yeah.
C is order 4, but this is not correct, right?
I think it
No,
is correct.
correct.
Yeah.
Because two dots are there. Okay, now
Yeah.
all
Yeah.
the
And
things
that
have two
petal.
dots. Yeah, that
Yes.
better.
Yeah.
And then multiple lines of symmetry is first one is two perpendicular lines of symmetry,
Right.
and the next is when the lines of symmetry change, but the degree
Yes.
remains the same.
Yeah.
And the last one is two lines of symmetry at 45-degree angle. So
Yes.
they were also coming to conclusion in a beautiful manner when they were seeing that this say 2b and 3b should have
Mm-hmm.
the same coloring, means the whole square should be
Mm.
colored the same. So they were
Right.
able to draw the connection of the angle and the degree of the rotation.
Excellent.
So So
Yeah.
that will come at the end when you had made the
Yeah.
table. There was a
Yeah.
table, yes.
Yeah.
And then mixing it up. So the first one is a line of symmetry and rotational symmetry of order 2.
Mm-hmm.
Then again, what if a different type of line of symmetry is selected?
Yeah.
And the last one is a line of symmetry and rotational symmetry of order 4.
Yeah. So,
So,
I mean, one of
and
the things that I think, I don't know if they observed it, like when it was the equilateral triangle, we didn't talk about different types of lines of symmetry. But when it
yes,
came to square, I mean, clearly in both, I think the multiple lines of symmetry, the second row and the third row, we are pushing them to think about different types of lines of symmetry because there are
yes,
two kinds. It can be, diagonal or the perpendicular bisector of parallel sides. So, did
correct.
anybody observe this?
No, I mean, I didn't come across
Okay,
such
okay.
student. Yeah.
So here is
Actually, they were.
something
Hmm.
that people can think about. Ki, I mean, when will you have more than one type of line of symmetry, and when not? So
Yes,
those are some food for thought that can come. And I mean, there are always some students who are hungry for more. So
of
these are
course.
some of the questions that are specifically for them, maybe not for the whole class.
Correct. So I think if we could spend some more time with the worksheet, we maybe they could have come with so many questions and so many observations, but that we couldn't do. That will come later, maybe. Okay. Then this is a common mistake which I have observed in many worksheets. Here the same thing, like the multiple lines of symmetry. Here when when we were asking to change the line of symmetry,
Uh-huh.
they just rotated the squares, it seemed. They did not
Ah,
change the line of symmetry. So this is one common error. But they could figure it out when I was actually telling them, when I was asking them to show me the lines of symmetry. They were able to figure out, for example, for the on the first row, the second, the green one, if the blue lines are the lines of symmetry, then this green should have, this
yes.
part should also be green.
Yeah.
Then actually this first square should be green, and
Right.
the third square should be green.
Hmm.
So this is a common mistake which happened for many,
Mm-hmm. Mm-hmm. Mm-hmm.
that can the same be done with other lines of symmetry. So they have chosen the lines of symmetry correctly, but could not reflect it properly. This also I had
Right.
asked them, just reflect and check if you are getting the lines of symmetry for that.
Mm-hmm.
All right, shall we move to the hexagon?
Yes. Yes.
Okay, this is the same girl who has done the squares. So again,
Uh-huh.
shall we go on with each one, because
Yeah. So
this
I,
there is.
yeah.
Hmm. I'll read it out because the questions are not here.
Yeah.
So 1A, again, it is simple ones. So exactly one line of symmetry and no rotational symmetry for
Hmm.
hexagon.
Hmm. Yeah.
Now this again had a lot of answers, many different kinds of
Of
shading.
course. Of course.
So now, the moment the lines of symmetry, number of lines of symmetry are increasing, the possibilities are increasing.
Right. Right.
Because for the squares, for the triangle, it was lesser number,
Mm-hmm.
and again for squares, it was more, and the hexagon, it's much more.
Much more. Yeah.
Now, the second one, B, is only rotational symmetry of order 2 and no line of symmetry. So, so again, I think it is followed. Yeah.
Yes. Yes.
One,
Definitely.
one, one C is rotational symmetry of order 3 and no line of symmetry.
Yeah.
So now they were able to see the connection that
Mm-hmm.
that if it is a hexagon,
Mm.
then what can be the different types of rotational symmetry of different
Uh-huh.
orders.
Uh-huh.
So, so for the squares also they could see that it can be, of course, 1, 2, and 4, and for this also it's 1, 2, 3, 6. So that they were
Uh-huh.
able to draw the connection that okay, this has to be factors and like that. So
So
that
so they
was
did arrive at that. So it is the
yes,
factors
yes,
of the number of
yes,
sides.
correct.
Okay,
So that they
excellent.
were
I mean,
able to arrive.
okay, okay, great, great.
And then the last one is only rotational symmetry of order 6 and no line of symmetry.
Yeah.
So this is another coloring. And then going to multiple lines of symmetry. So 2A is two perpendicular lines of symmetry. Now here also some of them were struggling to figure out the lines of symmetry because since there are six, so they were actually getting confused that which one to take and which one not to take. Then I asked them to actually make the lines of symmetry bold and do, because
Right.
otherwise it will be confusing for them.
Yes.
And
Yes.
then 2B is two lines of symmetry with 60-degree angle between them.
Yeah. Yeah. And you
And
can
can
see that this one has highlighted the lines of symmetries.
yes, yes. And the next one is with a different lines of symmetry, but angle remained 60.
Hmm. I mean, if I look at the two, if it 2B and
Hmm.
2C, they kind
Hmm.
of look like as if you have just reflected one to get the other.
Yes.
So I don't know
So,
if any of them observed that.
hmm, hmm, hmm.
I mean,
So
in
I
case
don't
of
know if they have. Hmm.
yeah, in case of square, it was very
Yes.
distinct. But here they
Hmm.
appear to be the same. Again, like some food for thought. I
Thought.
mean, did we get completely different thing in square, but not here?
Yes. True.
So, so if you try it out with the next batch,
Next
uh,
batch.
you know,
Yeah. Hmm.
yeah, then these are things. Then maybe you can ask.
Yes. Points to
Yeah,
discuss
again,
further.
yes. I mean, maybe not
And the
necessarily for everybody, but at
hmm,
least those
few,
who are
few.
finding it quite intriguing.
And again, this 2C and 3C will have the same coloring because this two
Yeah,
lines of symmetry with 30-degree angle between them.
yeah.
So this was also, I think, while I mean, only few could do the hexagon part. That is
Hmm.
another thing. But the students who could do the come to hexagon, they could see that from squares they were drawing some connections that when they were all having the same colors, that means the order has to be six. And these have some questions below them. So, for example, the second row, the questions were: does the colored hexagon have rotational symmetry? What is the order? Because this second row is only talking about multiples line of symmetry, but the following question was if there was any rotational symmetry. So she has written that yes, the first one has rotational symmetry of order 2, the second, this 2B, both of them have rotational symmetry of order 3, and the last one has 6. So
Yeah,
here also they were again seeing the connection that lines of symmetry is connected with the rotational symmetry.
yeah,
It's
yeah,
not two things, two separate things.
yeah.
And the last row is mixing it up. So the first one is a line of symmetry and rotational symmetry of order 2. So again there can be different coloring for this.
Yeah. And did they notice that 2A and 3A kind of are similar?
2A and 3A, yes, yes. So they were able to see that connection in the square as well, that there were the mixing up and the multiples have some connection.
Yeah.
And then 3B is a line of symmetry and rotational symmetry of order 3. So again this order 3 and a line of symmetry. And again the third one is what if a different type of line of symmetry is selected. So
Yeah.
she has
Actually, she hasn't not chosen a different type of line of
no,
symmetry.
no, no.
Yeah,
She hasn't
yeah,
chosen.
yeah.
And the
So
last
there,
one is, yeah, the last one is a line of symmetry and rotational symmetry of order 6.
yes,
So now again the questions followed, that does the colored hexagon have other lines of symmetry, and what's the smallest angle between two such lines?
yeah. So I mean, in a way, it is the reverse of two,
Exactly, the second
because
one.
here you
Yeah.
have the order of symmetry, and what can you conclude about the angle between two lines of symmetry, the smallest possible
Yes.
angle, whereas that one was about two lines of symmetry and the angle between them, and you have to figure out what is the order of rotational
Order.
symmetry. Yeah,
Yes.
so it's
Yes.
kind of visiting it from both ends.
Yes. So I think while doing it, they could see that
Mm-hmm.
if they could finish it till the end, they were able to see that.
Mm-hmm.
So now,
Yeah.
so small mistake in this.
Yes, yes,
It's the row one. That is the second one was asking
yes.
only rotational symmetry of order two and no line of symmetry.
Right.
So,
So the if the
so
triangle shifts a bit
yeah.
one to the left,
So
then it would have done it.
correct.
Yeah, yeah.
So the line of symmetry is correct, but the rotational one wasn't.
Yes,
So there
I
was
think, I
different.
mean,
Hmm, hmm.
the student was probably trying to ensure there is no line of symmetry, and therefore the confusion.
Yes, yes. So there
So
were
even
different
if
kinds
we,
of mistake actually, but
yeah,
I couldn't
even
take all of
1C
it.
for that matter
Hmm.
includes line of symmetry.
Includes
1C was
line of
not,
symmetry. No, it is only rotational symmetry of order 3 and
I
no
mean,
line
that's
of
what it's
symmetry.
supposed to happen. But if we
Yes,
look at the
yes.
coloring, it has
Correct,
lines of
correct.
symmetry. In fact, I
It
mean,
has lines of
if you,
symmetry. Yes. Hmm.
yes. So that
It
is also
is.
not a
Hmm.
correct one.
Correct.
Yeah,
Yes.
yeah.
If they if the child has done something else with the colored, if instead of
Right.
the two yellow, if
Uh
something
huh.
else could have been there,
Yeah,
then
yeah.
right.
Yes, yes.
So these are with the mistakes also they were able to understand, of course.
Uh huh.
So we are celebrating the mistakes and not telling them this is incorrect and all. So I
No, no,
always I told
that's
them
also
that
the,
keep them. Yeah.
yeah, yeah,
So
because they also learn, like, what went wrong, or what was
yes,
they doing that didn't work out, you know,
correct.
to track one's thought process, that is also needed. The other thought that I'm having as I'm looking at it, we give
Hmm.
a lot of MCQs and stuff, and I'm wondering
Yes.
that, for us also it is taking time to identify if there is a
Hmm.
mistake or not.
Yes.
So I
True.
was
True.
thinking, like,
Hmm.
if we give similar pictures and ask them to identify, like, which one has a mistake or something,
Hmm.
uh, that can also be quite intriguing. Uh,
Absolutely. Very
in,
interesting.
in terms
Yes.
of trying to
We,
spot. So maybe, somebody can design a similar worksheet, in MCQ or something
correct.
like that, where you have the
Hmm.
pictures, but you have to kind of read and decipher what the picture is about, what is has and what is
Absolutely.
doesn't.
Correct. Because why when they were coming and showing me answers, like I was after some time I was completely confused because so many kids, 50 students coming and showing me different
Yeah,
shading
yeah,
and asking me that is this
yeah.
correct or not, and to get
Uh-huh.
the mistake, to find out the mistake from there
Yeah,
was a difficult part for me while conducting it.
yeah.
Okay, and the last part was actually conclusion of the tear out. So they had to draw the connection and actually come to the kind of formula like order of rotational symmetry is equal to 360 divided by 2 into the smallest angle between the lines of symmetry.
Right, right.
Now this again, the students who has actually the students who have completed the squares as well as the hexagons and answered the questions for each one, they could do
Mm,
that.
mm,
But that
mm,
is maybe out of 50, it is 5 or 6 of them. They could
mhm,
complete the whole thing.
mm, mm.
So they were able to see the connection and do the, I mean, find out the formula and do it and
So, do you
generalize
think,
it.
like, is it because of lack of time, or do you think it's something else, like the where the majority couldn't finish it?
Oh, 1 minute. Okay. Yeah, so
Yeah.
lack of time, of course, it was there because, as I told, that they were having a 2 day maths workshop and that was for 3 hours. So the next day, the last day actually, they had only the tear out to do. Uh,
So this
but
they did
what
for one and a
happened?
half hour.
No, no, no. They had 3 hours to do this.
Oh, okay, okay,
Yes.
okay,
Okay,
okay.
but what I realized while doing it, that they it wasn't a great idea to give them 3 hours and make them sit and do it
Uh-huh,
completely,
uh-huh,
asking them to complete it at 3 hours. Of course they
uh-huh,
had some break in between,
uh-huh.
but they were getting too hecked up, I think, too
Yeah, I
much.
think they
So
probably reached some saturation point.
yes. So
Yeah.
because on the first day there were some different worksheet or different activities they had to do.
Uh-huh,
Second day I knew that they will take time. So I
uh-huh.
thought, okay, let me give them enough time. But I realized that the enough time should have been, over maybe 2 months or so. Maybe after one
Right.
month, I could have visited the hexagon again.
Uh-huh, uh-huh.
Maybe till squares, I could have just done it.
Yeah. And I was also thinking maybe the hexagon can be like, take home or something.
Yes.
That can be
So,
another possibility.
hmm. Because together doing it together at one point, I mean it was a bit too much for them.
Mm.
Only few could do that, but rest, I mean, after the squares they gave up. They said, ma'am,
Uh-huh.
can you give us
Yeah.
something else? I said,
Yes.
okay, I can give you,
Yes.
but don't you want to try? They said, no, we are very tired. I said, okay.
Yeah. Yeah.
So
So, I mean, what I think we had after this was, I mean, it was already given as optional, is to kind of think about, what would happen with regular pentagons and what would happen with regular octagon, for example.
octagon. Yes.
And
I
basically,
actually thought that we could take it up. I
uh-huh,
thought that with this few students only, maybe not 50, but with 5 also, if I can take it up, that will be good. But I realized that that is not happening. I mean, that
uh-huh,
was, I mean, I misunderstood it. That I should have, I mean, like curriculum part, we have like something we do in class 7 and then again in class 8. I think this is like that, so
uh-huh.
it shouldn't be done at one stretch.
Right, right. So, do you think some part of this could have been done in maybe, say, class 7?
Yes, I think as I told that this batch did not have any introduction to symmetry.
Right.
If they
That's the
had
pandemic
the
effect.
introduction, yes, yes.
Mm.
Because pandemic again, the curriculum was reduced, and of course, all these chapters weren't there. And online, I don't know, we didn't do all these things.
Mm.
So otherwise, they from class 5 itself they start symmetry. They do all
Mm.
the rotational symmetry, reflection symmetry as well.
Mm.
But this is
So,
different.
so that's what I was wanted to ask. Like, you have the symmetry chapters, which are, as you said, usually
Hmm.
neglected, done as some fun stuff when you have time.
Yes.
So, in terms of difficulty and challenges, etc., or even otherwise, how was this steer out compared to the chapters?
Yeah, so actually, that in symmetry chapters, all the answers have more or less the same answers. I mean, all the questions have more or less the same answers. So it's not multiple types of answers they have. So this is one such symmetry worksheet or exercise where loads and loads of answers were coming out. So that's the main difference,
Mhm.
of course. And so here the worksheet provided the a scope for the students to play around and discuss among themselves that
Mm.
this can happen and this cannot happen. He or she is correcting the others. Otherwise, it is always one answer that this has
Mm.
to be the line of symmetry. Otherwise, the figure is asymmetric.
Mm. Mm.
So this wasn't the case for here.
Mm.
And
So this gave them
again,
more to talk about.
a lot to talk about and do in hands with their own
Mhm.
colors
Mhm.
and everything. And also that the transition between the lines of symmetry and the rotational symmetry, there is no connection drawn in the book.
Mm. Mm.
So suppose I take class 6, what I was seeing in NCRT, that class 6 has reflectional symmetry, and class 7 or 8 I think have rotational symmetry.
Mm.
So
Mm.
they are two different things. I mean, there, of
Ah.
course, one object has rotational and one object has reflectional, but
Ah.
what
Ah.
are they doing together? That is
Uh-huh.
not there.
Yeah. Yeah.
So,
Yeah.
that was, of course, very much present in this worksheet.
Yeah. Actually, there is a
And
story behind that discovery, at least for me.
okay, okay,
The story kind of goes like this. At one point, and you may remember this, the West Bengal state textbooks, they did not have symmetry, but what they had was reflection, rotation, and translation.
hmm.
And
Translation,
you can break down translation as reflection onto parallel mirrors. Okay.
hmm.
And naturally, a question arises, what happens when you reflect onto intersecting mirrors?
Correct.
Okay. And
Hmm.
then you actually end up getting a rotation. Okay. And if you
Okay.
see
Hmm.
that, I
Hmm.
mean, just like when you reflect twice on two parallel lines, there is a translation, and the
Hmm.
how much you translate has something to do with this gap. Okay. Similarly, when you rotate, so when you reflect on intersecting lines twice, then the
Hmm.
actual rotation has something to do with this gap.
Angle.
Okay.
Yeah. Okay.
So
Hmm.
I mean, that's how I arrived at those things. And then
Okay.
when you are coming to symmetry, you have the tools, so why
Hmm.
not push them to explore something more, because ultimately they are older, they are much older children, and they, I
Yes.
believe, should be challenged to stretch their thinking and use what they
Yes.
know.
So that was another difference between the book exercise and this. That thought is not challenged enough.
Yeah.
Here, I mean, they love to do symmetry chapter because it is easy and it is fine, happy chapter.
Huh.
But
Huh.
it's not challenged. Like at the end,
Huh.
as they told me that, ma'am, I cannot do it further. So
Huh.
this was like,
Yeah.
yeah. So this is.
Also the kind of connections that they got in terms of, so the possible orders of rotational symmetry has something to
Hmm,
do with the number of sides of the regular polygon, right?
correct.
So there you are looking at making a connection between geometry and number and
Hmm,
factorizing and all of that. So
of course.
that, I think, is also something that is often ignored. Like when you do numbers, it is pure numbers, and then when
Absolutely.
you do
Yes.
geometry, it is pure
Hmm.
geometry, and you don't see the connections that they play.
Connection.
So,
Correct.
I mean, one thing that I will throw open for anybody is, like, for example, there were two kinds of symmetry for both uh, squares and hexagons, but only one kind of symmetry for uh, Equilateral triangles.
Equilateral.
Yeah, so what would happen for, say, pentagon? What would happen for octagon? Or probably a more interesting question would be what would happen for uh, a nine-sided regular polygon? Okay. And I mean, one way to think about it would be, I'm just giving hint, but not entire answer. If, I mean, if you think of the equilateral triangle and pentagon, then the number of sides are prime numbers,
Hmm.
right? On the other hand, if you think of a nine-sided polygon, regular polygon, then it's no longer prime, but it's an odd number.
Odd. Hmm.
So what really makes the difference? I mean, is it the parity or is it the prime versus composite? So those are
Correct.
things that one can explore.
Yeah, I also wish to do that because the generalization part we could not follow it up in this workshop. But I really want to take it forward because this has a lot of scope to find out different things in different grades as well. I mean,
Yeah,
it can be
yeah,
spread over in different grades. Maybe class
right.
6 can do a bit, in class 7 can
Yes.
they do a bit more, class
Hmm,
8 can
hmm,
they do a bit more. Yes.
hmm, hmm. So I have one more question because, so I mean, for each shape it was in three parts. The first one was just one symmetry and that's it. The second one was two lines of symmetry, and the third was a line of symmetry and rotational symmetry. Now,
Hmm.
out of these two lines of symmetry or a combination of line symmetry and rotational symmetry, which did they find more challenging?
I think the lines of symmetry part.
Multiple lines of symmetry.
Yes,
Okay.
multiple lines of symmetry, finding the
Uh-huh.
angle and actually selecting it. Because
Uh-huh.
for me, that was also very, I mean, surprising that I felt that the rotational symmetry part will be difficult. But after a certain point after the equilateral triangle part, they were quite comfortable with the rotational part. And
Mhm, mhm.
reflectional was becoming difficult.
Uh-huh.
So that
Uh-huh.
I figured out. I mean, I was thinking one way and I found it's not
Yeah.
that way actually.
Yeah. Yeah. So we would like to open it up for any questions or any comments from the our audience. So please type it in, and we would like to answer it. There was one question already from Suresh S. On in terms of uh, is there a way to enroll in the I think you he meant the curricular material development course. That course has changed quite a bit, and the only way you can enroll in it is if you become a full-time student at of MA education, Masters of Arts education, and it's a full-time thing, 2 years involvement. We do not have it in any other form as of now, uh, so I don't think it will be possible to give you that flavor. So uh, there is a question for Kritika by Gauri Satya. Were there students who were willing to explore an open-ended manner in an open-ended manner like this? Uh, so
Okay, so I don't know. Actually, this batch has done quite a lot of activities with the open-ended questions because I was teaching them from class 6 and we had quite a bit of activities which had this peer group discussion and questions which are not which do not have only one set of answers, so they were familiar with that. So I think they were not too unwilling to have open-ended questions, but unwilling to continue with the worksheet for a longer period of time. That I was able to see. Yeah. I mean, only few.
Yeah, but this is something that I think one should keep in mind. I mean, this is for all our viewers. Usually, each tier out packs quite a lot. Okay,
Exactly.
and that is probably because we tend to go gaga mathematically and make a deep dive and try to look at all, I mean, really reach as much depth as possible and so on and so forth. Now when you take it to class, in a student with all students, and some of them may not be that enthusiastic about mathematics, of course, like Kritika did, you should definitely try it out on your own to get a sense of where it goes and what it entails. But I think it will be a good idea to portion it and,
Exactly.
do parts of it across maybe different classes, etc. Maybe even different years, and
Different years.
not put do everything all together.
So that was,
So
this is first time I was doing it, so that was a learning experience for me.
yeah,
That we should stagger it out
yes,
throughout the term, or maybe on 2 years or so,
yeah,
because it
and
has a rich, yeah, rich questions, and a lot of things to talk about. So we should not limit it to one single day. So
right,
that is
right,
another thing.
yes, yes, yes. And I mean, and not all of them, like this is connected to syllabus to an extent, though it goes
Exactly.
beyond that. There are some tier outs which are actually, going into newer territories, some very deeply connected uh, with the syllabus. In fact, some have been are on specific misconceptions, like to address certain misconception. But some are more, you know uh, trying to have fun with mathematics. So there is another thought from Gauri. Orally one on one with the individual students. uh, Okay. So I'm not sure if I understand this. She's saying orally one on one with the individual students, or jot down the questions on the board, or jot down one. Yeah, there it
Actually,
is.
it is coming from the previous question. So you
Right,
spoke
right.
of the extension questions for some students who are ready to take it to the next level. I wondered how would you implement this in the classroom, orally on one to one with the individual students, or jot down the questions on the board, or jot down one and one for each student.
Okay. So yes, you can jot them down on the board, because then it opens up to the entire class. Whoever wants to attempt it can attempt it. Okay, I mean, if you have like a math club or something, then that is another forum you can use. So I won't say, I mean, one to one you can do is, then you have to repeat yourself too many times, right? So maybe the first time somebody asks, okay, I'm done, what do I do next, or is there anything else or something, maybe that is your cue, and you can start putting them on the board. So next time anybody is done, you can again point them out and kind of keep them engaged.
Right.
So that brings us to 5:30. We are dot on time. And since there are no more questions, I think we can wrap up this webinar here. So thank you all for joining us about Simply Symmetry. We will see you again next month.
Thank
Bye
you,
from me.
everyone.
Thank you,
Bye bye.
Kritika.
Bye. Thank you,